Good morning, everyone. Myself Devika, working as assistant professor from the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today we have learned about the subject W25C01 Basic Electrical and Electronics Engineering for a second semester as per Regulation 2022. Today, I am going to present statically and dynamically induced EMF, which is an important topic in basic electrical and electronics engineering. In this presentation, we will learn about EMF, Faraday's law, direction of induced EMF, and types of induced EMF. Introduction to EMF. EMF stands for electromotive force. All metals contain a large number of free electrons, which move randomly inside the metal. When a battery or a voltage source is connected across a metal, these free electrons start moving in one particular direction. So the electrical force or pressure that causes this movement is called electromotive force. The unit of EMF is volt. The, then Faraday's law of electromagnetic induction. Faraday gave two important laws to explain electromagnetic induction. First law, whenever the magnetic lines of force linking with a conductor or a coil change, an EMF is induced in it. Faraday's second law, the magnitude of induced EMF is directly proportional to the rate of change of flux linkage. That means EMF is denoted as E equal to minus N into del pi divided by del T. N is number of turns, del pi is rate of change of flux, del T means rate of time. Next one, direction of induced EMF. The direction of induced EMF and current is not random. It depends on direction of magnetic flux, direction of motion of the conductor. There are two methods to find the direction of induced EMF. One is Fleming's right-hand rule, Lenz's law. Fleming right-hand rule. In Fleming's right-hand rule, first finger indicates the direction of magnetic field. Thumb indicates the direction of motion of conductor. Middle finger indicates the direction of induced EMF or current. This rule is mainly used for generators. Lenz law. So Lenz law was stated by Heinrich Lenz. It states that the direction of induced EMF is always such that it opposes the cause that produces it. This opposition is represented by a negative sign in the EMF equation, which is due to Lenz's law. So, induced EMF E equal to minus N del pi divided by del T. We know that E means induced EMF, N is number of turns, del pi means rate of change of flux, del T rate of time. Then, types of induced EMF. Based on the nature of induction, there are two types of induced EMF. One is dynamically induced EMF. Second one is statically induced EMF. Statically induced EMF is further classified into self-induced EMF and mutually induced EMF. Dynamically induced EMF. Dynamically induced EMF is produced due to the physical movement of a conductor in a magnetic field or a magnetic field relative to the conductor. Here, magnetic field is stationary conductor cuts the magnetic flux. This principle is used in electric generators. Then, magnitude of dynamically induced EMF. When a conductor moves parallel to the magnetic flux, the induced EMF is zero. Then the conductor will have to rotate the conductor. So now when the conductor moves perpendicular to the magnetic flux, so that it cuts the all flux lines. So the induced EMF is maximum. So maximum EMF is produced when the conductor cuts the magnetic lines at right angles. That means theta equals 90 degree. Next, statically induced EMF. Statically induced EMF is produced without any physical movement of the conductor. Here, conductor remains stationary. Magnetic flux linked with the conductor changes with time. This happens due to a changing current in the coil producing the magnetic field. Production of statically induced EMF. In this case, an AC source is connected to an electromagnet. Due to AC, current changes with time. Magnetic flux also changes with time. This changing flux induces EMF in the coil, which is called statically induced EMF. So the application of induced EMF is dynamically induced EMF is used in generators. The statically induced EMF is used in transformers, inductors, electrical machines. Conclusion. To conclude, we have studied meaning of EMF, Faraday's law, direction of induced EMF, dynamically and statically induced EMF. These concepts form the foundation of electric machines and power systems. Thank you for your attention.